Hello, everyone. We are excited to have you today on our Immersion Day event dedicated to the topic of machine learning with Amazon SageMaker. This event is brought to you by Provectus and AWS. My name is Yaroslav Tarasuk. I'm a part of Provectus team. I will be kicking off our session today. A few notes before we begin. As we move through the content, you are very welcome to post questions in the GoToWebinar question tab on your right. Our team will do best to address them during the session and after on the Q&A session at the very end of the Immersion Day. We will also run a few polls during the session. Please participate, your insight is valuable. We will also provide to every one of you a recording of this session after this call in the follow-up email, and you will have all the useful links shortly after the webinar. Agenda-wise, today, we will learn how Amazon SageMaker can help you build, train, and deploy machine learning models easier, faster, and at scale. So our expectation is that audience is familiar with the AWS in general and with Amazon SageMaker in particular. We will start the quick overview of Provectus right now, make very quick introductions of the host, and then proceed to the session according to the agenda. All right, so a 90-second overview of Provectus. As a company, we are obsessed about extracting value from data through AI and deploying it to the real world. We provide an end-to-end solutions for business, and we consult technology executives on machine learning and data engineering teams on how to build foundational components like enterprise-grade data machine learning platforms. Quick facts about Provectus. So we are headquartered in Silicon Valley. We are a 10-year-old company, currently have 500 employees worldwide. And we serve clients ranging from cutting-edge startups to Fortune 500 enterprises. We are proud to be an AWS premier consulting partner specialized in AI/ML. Competency-wise, we believe in the convergence of DevOps, data, and machine learning. This is why this is our core focus. Some of our lovely clients are listed here. So we are comfortable working with big enterprises and driving multi-million transformational projects, as well as helping startups, partnering with them from the very early stages through all of the funding rounds and successful acquisitions and IPOs. With that said, I would like to proceed to the introductions of our presenters today and pass it over to my esteemed colleagues. Rinat, please take the stage.
Hi, everyone. Hi, everyone. My name is Rinat. I'm solution architect from Provectus. Yeah, so half of my experience is academic and half industrial. The recent years, I've focused mainly on natural language processing problems and machine learning ops. And Provectus has extensive experience with SageMaker, which will be our focus today. So next, I will pass over to Rinat.
Good morning, guys. My name is Rinat also, Rinat Akhmetov. So I'm a computer vision engineer and solution architect at Provectus company. And most of my life I dedicated to working with computer vision programs and processing video streams. So I will be happy to drive a lab for you today. I give a word to Bulat.
Hello, everyone. My name is Bulat Lutfullin. I am an ML engineer at Provectus, and I am working on MLOps. So we create solutions for monitoring and deploying the models. Today, I will host a lab session number 1 about feature extraction, and that's it. And Friday.
How you guys doing? My name's Freddie Costas. I am a solutions architect in the startup pillar for AWS. I've been with AWS now for a little over 3 years. Hoping to help you guys learn more about more about AWS and build as much as you can.
Good morning, everyone. My name is Chaitra Mathur. I'm a senior solutions architect at AWS. I've been here for 3 years. I'm a generalist, but I'm trying to build my area of depth in machine learning. And it's been great learning about machine learning and doing that in AWS. And I hope you guys learn a lot today. And welcome.
Thanks, everyone, for the introduction. I think we should be having a welcome note as well from AWS. So I'm passing it over here.
Yes, I would like to welcome David Grimm, a special guest today. He's the head of partner solutions architecture here at AWS, and he and his team focus on enabling customer business outcomes, modernization of application through prescriptive architectural guidance and differentiated customer experience. He leads an Americas team of solutions architect, and I am part of it. And we support critical customer activities, and we leverage partners like Provectus, who are awesome, by the way, and work with senior stakeholders within customers and partners to ensure successful migration. Over to David. Unfortunately, he's having some video issues, but you can hear him clearly.
Thank you for the welcome. And yes, I'm having some video technical difficulties, but good morning, everyone, or good afternoon, wherever you may be joining from. And thank you for attending one of our many AI ML events that we're doing with our partner Provectus. And I want to just reiterate, this is not going to be a sales and marketing event. It's going to be a deeper technical education event. So I would urge you to please take advantage of the labs in the sessions today. So dive deep and learn what we have to offer here. And as the introduction showed, we've got a great team of senior architects here to help you along the way. Before we get started, I just wanted to share a few thoughts with you. So when we think of application modernization, two things are very important in this space. One, the right culture that drives invention and innovation is super important, as well as the technology that supports all of you in achieving these goals. And one thing that our customers continue to ask us is that we push the envelope on price and performance. And AWS is a very customer-obsessed company, and it's really our mission to deliver and delight our customers on these things. And so as a segue to that, I'd just like to take a moment to highlight some of the new services and features from reInvent 2020 and in the recent months that were announced, and really focusing in on the industrial AI services space that are now available, and put these services in the hands of all of you as developers. Such as Amazon Monitron. And this is a service that allows you to monitor the conditions of your equipment in your facilities. Panorama is another service that brings computer vision to on-premise cameras that make predictions with high accuracy and low latency. So our customers have shared with us that data preparation makes up about 80% of machine learning development, which is almost the bulk of it. So this is why we introduced a service called SageMaker Data Wrangler. And that service, literally with just a few clicks, you can drastically reduce the data preparation time for your AI and ML models. And another service, SageMaker Clarify, is a service that detects bias in AI or ML models. And this is another service that our customers have been asking for. So what I really get excited about in terms of features are the ones that improve speed and reduce cost for our customers. And one such feature that I'd really like to highlight for you today is a feature called data parallelism. And that feature reduces the distributed training cost by up to 1/10, which really allows teams to get results much, much sooner, iterate faster, and accelerate the pace of innovation. So there's many more exciting features in our AI and ML stack. And I'd like to let the session leaders and the presenters today cover those with you. Before I let you go off on the sessions and the labs, I really want to thank our great partner, Provectus, and our broader APN partner network for their great partnership. And a few things I'll say about our partners. They have really been early adopters of cutting-edge AWS technology. They're experts at helping you, our customers, modernize in the cloud. And they really bring skills to help our customers design, deploy, optimize, and manage innovative cloud applications and infrastructure. So I really want to thank Provectus and their continued great partnership. And I know we've got lots to cover today. It's a packed agenda, so I want to let you have at it. But I'll really just close by saying, take the time today to explore, ask a lot of questions of our experts, and really experiment, and more importantly, go build. So thank you for having me today, and have a great session. Thank you very much. I'll turn it back over to the team.
Thank you, David. That was great. Thanks for joining us. Let's kick it off. Let me just get my content up. And okay, share my screen. Okay, I hope you're able to see this. So in the next 1 hour, we will be covering some introduction to SageMaker. Before that, few concepts about the machine learning process. Then we'll cover SageMaker. We'll touch a little bit upon data engineering, feature engineering, and the tools available within AWS and within SageMaker that help us accomplish that. Now, before we dive in, I had a quick poll for folks. If you're able to see this on your go-to screens, just a quick question on how familiar are you with the AWS set of services for machine learning? There are a few options. Please, let's take 45 seconds just to answer this. There is no good, better, best here. We just want to understand what the makeup of our audience is today. Just another stat that will help us go through this session with that in mind, and maybe help each of these different categories today, and also better plan, future sessions. Now, when we have sessions like this, what kind of experience do people bring in? I see there are a lot of answers coming in. Let's give it 5 more seconds. Okay, let me close it. Share results. Okay, we have more than 50% who have just started with AWS machine learning, probably. Some experienced, no experts. That's surprising. Nobody wants to call themselves an expert. I totally understand. Okay, so thanks for taking that poll. Now let's just dive in. We have seen that machine learning is extremely,
Chaitra, yeah. Please close the results so that you can keep sharing your screen, keep sharing your slides.
Yes, I have closed it.
I can still see it. Please plus in chat if you still see it, just like me.
Are people still seeing the poll, or are you able to see my screen?
I can still see your poll. Audience.
So
Could
I don't
folks
see
just
Yaroslav. Maybe it's your screen.
Yeah, okay. Yeah, if people could just put a +1 on chat if you're able to see my screen, wherein it shows different use cases instead of the poll. That would really help us. Okay, I guess I will continue. Okay. Okay. Thank you. Machine learning is becoming very pervasive. I think at some point, large number of applications will be infused with this, right? We have different use cases here, and we see this very, very common. For example, predictive maintenance, right, in manufacturing. You really want to know failure before it happens, whether it's fleet of automotive machinery, whether it's IoT sensors, and demand forecasting, right? You want to be able to forecast inventory or pricing or purchasing. Really helps the retail companies. Fraud detection, you want to be able to identify a fraudulent activity and flag it for review. Improves customer satisfaction actually. And then if we jump to computer vision, in an automated fashion, if it can look at your x-rays and any other imagery and make a medical diagnosis and recommendations, again, retail, where it can look at your past history and even live events that are happening based on your purchase and give you really good recommendations, right? And these are some of the very common use cases we see. I do have another question to ask people. If you can take this poll for me, please, so that we understand what kind of use cases are you looking at in your organization. I'm assuming you're able to see this. And this is just to understand whether, what kind of use cases are we looking at with the audience that have arrived today. If you're just here for learning, you can select other. If it's one of the cases that is not mentioned in the list, please select other. Let's just give it another 15 seconds. Oh, that's interesting. I see evenly spread out responses. Oh, that's great. Okay, let me close the poll and share the results. Yep, NLP, a lot of NLP, forecasting, classification and regression, right? That's a classic case study. Okay, let me close this. And okay, I really hope all of you get things out of this session and you're able to take something back from today and apply to your specific cases. So typically machine learning has been very complex, expensive, right? If you look at every step of the life cycle, you are facing a lot of barriers, right? From collecting and preparing data. It's time consuming. There's a lot of undifferentiated heavy lifting that you have to do historically. Then, choosing the right ML algorithm, a lot of trial and error, and very lengthy training times leading to higher costs. Then there is model tuning where you are working with thousands of different combinations to find that perfect model for your use case. And then if you look at the traditional software development, all those are very disconnected in machine learning world, right? Be it debugging, collaboration, continuous integration and deployment. So there are a lot of barriers that we have seen in the space. And we will come to the point where we see how do we really overcome these barriers with AWS services. Now, just to set the stage, what does an ML process look like, right? You have a business problem, right? This is a very critical step. You have to frame the problem really well because not everything needs a machine learning solution. You could apply probably an if then else loop, heuristics. So you really have to think, is it a machine learning problem? And once you have that, you have framed your problem, and you have to frame your problem in a machine learning sense, right? And then comes the data collection. So you have many different disparate sources. You have to bring all of the data together in one place. You need massive storage probably. And then you're embarking on, the data engineers are embarking on this cleansing and preparation of data. And yet it's not ready for machine learning. You have to do more, right? You have to understand what this data is. You have to analyze. You have to see if there is missing data. You have to see if the data makes sense for the machine learning problem, right? You have to convert some of the data to, you have to encode it. Maybe you have to do one-hot encoding. Maybe you have to drop columns. Maybe there are not enough features. So you have to spend a lot of time in just feature engineering. That is what we call feature engineering. And then you select your algorithm, you start training, you start tuning, and then comes the evaluation, right? So different types of algorithms, whether it's classification, regression, they have different evaluation metrics, right? For example, classification, you can have accuracy. In binary classification, you can have area under the curve. For regression, we measure something called root mean square error. So you're measuring and you are comparing, is it solving my business need? If not, you start all over again. Maybe not all over again, but you're actually bringing in more data. You are doing more feature engineering. So this is a continuous loop till you're really happy with your model performance, model evaluation. And then the next step is model is ready. You want to deploy it for real-time inference, right? That is when you deploy it. And then you want to continuously monitor it. You want to see if there is a drift. You want to see if the model is performing well in the real world. What are the factors that's really affecting this? You want to collect that and probably retrain. Maybe the data that it is seeing was never seen before, and you want to incorporate that data in retraining your model. So again, just reiterating, when you frame the problem, you need deep domain knowledge, and you need to understand the business objectives. And which category is it? Is it a classification, or do you want to predict a number? And just lay out the plan for how this project will be executed. Then we have data collection, integration, preparation, and there are many AWS services available for this, right? I mean, someone said at a time that AWS is like Lego blocks. So we have Lake Formation, which is a fully managed service. You can build a secure data lake, and it automates a lot of complex tasks. AWS Glue, it's a managed ETL service. And EMR, it's a managed cluster platform. You can have your Hadoop or Spark clusters there. Athena, a query service for S3 data. Amazon QuickSight, which is a BI tool. And SageMaker itself, which is a fully managed ML service. So there are so many different tools you can use based on what kind of data do you have, right? Glue is highly scalable. However, if your organization has invested in, let's say, Spark, you could use EMR and you could use Spark for data processing. Right? It really depends on the requirements you have, the data you have, and the skill set. Okay, so moving on. Next, we come to visualization and just a model training, tuning, right? What SageMaker does is removes a lot of the undifferentiated heavy lifting. You are able to label data at a very low cost and low effort. And it's a managed environment for Jupyter notebooks. If you don't know what a Jupyter notebook is, it's a tool that you can write your code and any kind of comments that you want on a web page, kind of an visual interface. And you can really build powerful things in that. You can do data engineering using NumPys and Pandas, and you can train your model. You can even deploy your model endpoint. Really, really good and powerful. And then SageMaker allows you to, provision clusters for your inference and training. And you can scale it for training really large data sets, right? You can even have distributed training. That's a new feature that was introduced, which is really, really good. And if you see at the bottom, it supports most of the popular frameworks that we have, TensorFlow, MXNet. So you can easily bring your own flavor to this. You can either use SageMaker's built-in algorithms, or you could use one of these frameworks and deploy your own algorithm and model building using one of these. Next, when you come to model deployment and debugging, right? I think this is where you hit a snag generally, because you have everything. How are you going to really scale this, right? Model deployment means you are putting it for real-time inference. There could be batch inference. So how do you productionalize this? And there are ways to do this. SageMaker allows you to deploy. You can, front it with a Lambda API gateway, give it public access. But the bigger thing here is the MLOps, right? So really making it ready for production. And at scale, you have to embrace machine learning, which is operations, right? And for that, we have many tools, SageMaker pipelines. You could even use step function. You could leverage one of these developer tools that we have, the code commit and the code build family of tools. Why AWS for ML? This is just a sales slide, but I really like it because it highlights a lot of the things. For example, just in the recent past, there were 200+ new features just in machine learning, right? Before SageMaker, even myself, I was very, very intimidated with machine learning. I thought it was for, scientists. I'm not a scientist, so I really struggled. I avoided it. I didn't want to really understand it. But SageMaker has made it really, really simple, right? Easy, low cost, customer can use their data better. It caters to a lot of different kind of roles, right? Developers, scientists, data engineers. The thing that it does well is it accelerates your adoption, right? I can quickly use the AWS console, go to SageMaker and start writing my first notebook, right? That easy adoption is going to reduce your TCO, cost, etc. And I don't have to stress on the third point. We know that AWS is the most comprehensive, right? Highly scalable, highly secure. We really pride ourselves on that. So imagine a stack built on such an infrastructure, right? What more can we ask for? Okay, looking at the ML stack, we have categorized it into 3 different layers, right? And if you can, if you look at this, we innovate a lot, right? And this has developed over the years, constantly talk to our customers, what do they need? And out of that, this is a fruition effort out of that. The top layer is the services, right? For developers who do not want to get dirty in ML, right? You just want to use it like an API. So these are pre-trained models, and you can easily integrate these into any of your applications and build intelligence. And this can be even within a few hours, actually. And I encourage everyone to go to the AWS console and just play with these things. For example, if you take recognition, you have a way to just upload an image right there and see how the model works, right? You get an immediate answer. And these are some of the services that can be easily integrated, whether it's a mobile app, whether it's a web app, any kind of app that you really want to build intelligence in. Then you have the middle layer, SageMaker. I say, okay, this is for me. I'm not an expert, I'm not a scientist, so SageMaker works perfectly for me. This is for developers and data scientists, where you're able to build and train and deploy machine learning models, and at scale, right? And every barrier that we talked about in the earlier slide, this eliminates those barriers. And then at the bottom layer, we have for expert practitioners. I'm sure, I think Rinat is one of them. So not me. So you can, really develop on the framework of your choice, or you can use SageMaker's built-in algorithms, or you can use a deep learning machine images. If you know Amazon machine images, these are images that are available within the console, and there are different kinds of images based on what you want to do. So we have specific deep learning AMIs where you can go crazy, write your own code. Okay, transitioning to SageMaker. So what is SageMaker? If you look at it, the right side is a screenshot of SageMaker Studio. However, SageMaker is larger than that. It's the most complete managed service. So when we say managed service in AWS means you don't have to worry about servers. You don't have to worry about really those provisioning and trying to understand the cost. SageMaker does that. That's what we have managed service, and this is for data scientists, ML practitioners, and you can focus. So when you start using this, you will see that you can focus more on the business problem at hand rather than trying to figure out tools and how do I scale this. And SageMaker helps you accomplish. And what the left side is trying to tell us is, you can think of it as a workbench, collection of things, which is the SageMaker, the Jupyter notebooks that you have. You have Amazon, we have the Studio. Studio is nothing but an IDE. We'll look at it a little bit later. And then it is built on this managed infrastructure, right? You're getting high throughput, low latency. And SageMaker takes care of that. You tell it how many instances you want and what kind of instance you want, whether you want a GPU powered, whether you want something else, whether you want influence. Those are the latest, that's the latest innovation that we have done in EC2 for machine learning, right? And then on top of that, you have a set of tools, for example, like Data Wrangler that David talked about, and tools that can help you detect and possibly mitigate bias. And we'll look at some of those later. So I think it's a really comprehensive set of tools. Now, what are we getting out of this? One is agility. You are able to get in, start the work, use these tools, and instead of months and months of ML development, now you could achieve in weeks and sometimes even days, right? And increase productivity. Once you get into the SageMaker Studio, and today we will do the labs in that, you will see that it's not just an IDE, it's integrated with some of the most powerful tools that we have built for every part of the machine learning lifecycle. And of course, cost, reduced cost is the fundamental thing with AWS, and it permeates to machine learning as well. Studio, what is this? It's a IDE. If you've used IntelliJ, if you've used PyCharm, any of those IDEs. So this has been a real innovation, right? IDE for machine learning was unheard of. And this is, once you start using it, you will see that you could do data visualization, data transformation, you can run experiments, you can train your model using notebooks that are available within the studio, you can debug and monitor. You really don't go out of the studio environment, right? And the best part is they're all tracked within this environment. So you can quickly move back and forth between various steps within your life cycle, right? You don't have to, instead of using multiple tools in multiple places, you have this one cohesive environment where you can do a lot of these, the full life cycle of ML. Just some screenshots. So if you look at this, this is so powerful. On the left-hand side, it's a notebook. You're building your model, you're training your model. And the right-hand side, you're actually measuring it. You're looking at the quality of the model using something called experiments. This is one of the trials of the experiment. So you really know, it takes a little bit of data set and it says, how is your model performing? This is so powerful, right? I can just go keep tweaking my code to make it fit. And of course, this is a notebook instance within the studio. So you can have Jupyter Notebook outside of the studio in the SageMaker console when you go to the AWS console, or you can use a Jupyter Notebooks within the studio as well. And they are the same, they give the same capabilities. You can select the instance type you want, and you can select the kernel that you want, all similar functions, but given inside an integrated environment. Now, I think this slide is great because it gives a sense of how comprehensive SageMaker is and clearly categorizes into these different categories. So first is the data preparation. Then it's the model build phase. Then you have the model train and tune. And how do we really deploy and manage? And look at the set of tools we have, right? And these four really address what ML machine learning builders really need in the full life cycle, if you see. Now, I want to do something. I want to take a quick pause and see if there are any capabilities that you see listed here, which may be of interest to you, right? I don't want to do a poll, but if you can use the chat feature and, just start putting, what do you think is really interesting to you, or your organization might be using it or are already using it, could be any of those. If you could just put some things on the chat so that we understand what you're really looking for. Maybe I'll just give 30 seconds for people. If you don't know how to use chat, it is on the webinar app at the bottom, and just start typing there and send it to the entire audience. If there is no answer that comes up, I'm going to assume that nobody's listening. So let's take 30 seconds if you want to just start putting your answers. Okay, I'm assuming nobody wants to share. Anybody? If not, I'm going to assume that, we have
several questions. We have several answers on between questions. Please take a look there into attendees and you will find it.
Okay. I was not able to hear clearly, but okay. Let's move on. I'm going to assume that we have audience who are interested in all of these. Today, we are going to hit the first two categories, which is the preparation, which I'm going to cover, and the build, which Rinat from Provectus is going to cover. So moving on, feature engineering and data exploration. We saw this slide just to center ourselves. This is the first category we are talking about, right? Where you're really trying to collect the data, process the data, do feature engineering. And David covered this a little bit, that we see that 80% of the time is really spent on data prep. Imagine an entire machine learning lifecycle and you're spending 80% on it, right? Because data is not clean, it's dirty. You're getting it from so many different sources. And you need tools to really clean that data, maybe do deduplication, maybe figure out why there are so many empty data and somehow try to fill it up, maybe try to figure out outliers. So this part, typically when you think of machine learning, you think about algorithm, model, how to train. But I think the key to that is having good data, right? So we saw this, the life cycle of data preparation. And yeah, sorry, I'm getting these notifications which I forgot to turn off. Hopefully you guys are not seeing it. You're collecting data from different sources, right? And it could be databases, data warehouses, and third-party systems. There's so many different sources these days. There's so much of data. So you're collecting it. You need massive amount of storage, which AWS has, called S3. And then you have to prepare this data, right? Maybe it's, standardizing date format, or maybe you are converting, numbers into floating points, and maybe there are multiple rows identifying the same entity, and you want to combine it, right? You duplicate. And once you prepare the data, it's still not ready for machine learning. Yes, you have cleaned it, which is awesome. Now you want to transform that data. And transformation is typically feature engineering, right? You want to see how this data looks. You want to analyze the data, and then you're applying some of the feature engineering things. And once you have done this, let's say locally you are working on a subset of data, you take 100, 200 rows and you're working, you have the code to transform. That's not the end of it. You have to put it in production, which means this code has to run for massive amounts of data now, right? And that traditionally, historically, you need IT teams, provision really beefy servers, and that has become easy with AWS. Just some examples of different feature engineering. If you have done that before, if you have not done that, don't be intimidated. Once you start this journey, you will understand what these different kinds are. You want to find correlation. You may want to merge columns. You may want to drop some columns. You want to find outliers, because those can really skew your model. And then the classic and the most, the feature engineering that's done very, very commonly is encoding, right? You have label encoding and you have one-hot encoding. Now, if you look at this, label encoding is you're taking your company name and you're converting it into numbers. You can convert it into simple numbers, but then you don't want ordinality. You don't want Acura to be better than Honda. Maybe it is, but you don't want the machine learning to think that there is some relationship with that. So you want to do one-hot encoding, which is basically this. You're converting it into binary. And here is an example of using pandas library, which converts and the columns you specify into one-hot encoded values, which is awesome. I love pandas. And then you have these some other thing that I'm going to skip. Next we come to, okay, I have data. What do I do now? You have to split the data because you get only enough data. You don't want to use all that for training. How are you really going to test the model? So if you are really solving a supervised algorithm, if it's a supervised problem, then you need labeled data. That's another challenge. And once, let's say you have labeled data, we'll cover in a few slides how to overcome that challenge. But let's say you have the labeled data, you are splitting it into training, validation, and test data. Training data is something that the model sees and learns from it, right? As it's training, it's going through this training data to generalize the problem. Validation data, it's used by some algorithms, it's not used by some algorithms. This is really to assess the model performance in the training phase. Then you have set some test data, which the model has never seen, and it never learns from it. It is to see if the model is predicting the way we want it to, right? And just an example of SageMaker. So SageMaker has Python SDK. This is an example using the Python SDK. And a very simple way, the APIs are super simple. The SDK is very, very intuitive. The documentation for it is awesome. So this shows how do you pass these into, these various what we call channels, right? There's a training channel, validation channel, a test channel, and algorithms can use 2 or 3 based on what kind of algorithm that is. Now, data processing, in a nutshell, what the slide says. So means you want to convert the data to solve an ML problem, right? Algorithms expect data in different formats, and you want to do engineering to give that so that the model can learn and predict better, right? To transform features, you're even scaling and normalizing. Maybe there is data that says, an age of 5, but the rest of the data is, I don't know, 99. You might want to look at how to probably scale it so that ML does not, use these outliers and your model can get skewed. And you can, more engineering. Maybe you want to extract the day out of the date, and that adds more value to your model than using the data itself. So there are many things you can do. And what SageMaker gives you is something called SageMaker processing job, wherein it pulls in a container, it takes the input data, and it processes that data and gives the output back. Now, what it does, what is the processing? You provide the script. It is so simple and so powerful. When I stumbled upon it, I was actually not aware of it. And we went to one of the customers, and they were so amazed by this because they are a typical Spark shop, and they wanted some infrastructure that takes this part. For example, Glue uses PiSpark, but they don't want to do entire data processing feature engineering for machine learning in Glue, although you could do that, but that's not a purpose-built service for that. So if you look at this, there is the compute instances that it pulls for processing your code. You can specify what kind of instance. You can even specify how many instances, and then it pulls the data out of S3, and then after processing, it stores the data in S3. You can also store it in feature store, which we'll cover in some time. And you don't have to use the containers, built-in containers. You can bring in your own container. So imagine the power of distributed processing that you get of Spark if you have really large sets of data, right? So the advantage of this is that you don't have to worry about provisioning, right? Typically, if you look at Spark, let's say you're doing it on EMR, you have to manage all of that. But here, what SageMaker does is it spins up these when the job starts, and it gets rid of the resources once the job finishes. So all you have to worry about is the cost during that, the cost that you incur during that, and to provide a good script, right? So here is the PiSpark, the Spark processors using whether PiSpark or Java. So you just use this processor, you give it a Python script or a Java code, a jar, Java archive, and it will process your data. Or if you want to do data processing using scikit-learn, that's another framework that's also available. Or let's say you don't like any of these pre-built Docker images, you want to bring your own because maybe you want to add libraries that are not there as part of these containers. So you could do that too. You could bring your own container and you could process the data, give it a script, everything remains the same, but the most complex thing is building your container. And there's really good documentation of how you could do that. That's the sample code. Here, we are using the Spark processor. I'm giving it how many instances. I want an M5 of the machine learning instance. And then this is the one that runs the job, right? So during this job, it has provisioned these two instances. You are giving it a preprocessed .python script. So what is the script doing? It's doing all of the feature engineering that you want. And now it's able to use the Spark's power of distributed processing, and it's able to transform this very large data set. Whatever you built in your dev environment, now you can productionize. Okay, I know I have probably 20 more minutes, so let me go through this quickly. Data Wrangler, a very, very, very powerful feature of SageMaker Studio, right? So with Data Wrangler, you are able to import data from different sources, whether it's S3, Redshift, Lake Formation, and even feature store. You can write queries to extract data. You can get data in CSV, Parquet, many different formats, right? And then you can transform that data. Means there are some pre-built transformations, and there are many, many of them. If you want to encode your data, if you want to drop your columns, and there are many other conversions that are available, but you can also write your own code in PiSpark or SQL or Pandas and give it to this transformation engine. And once the data is transformed, you can visualize. You can see how the data looks. It's not just visualization. Yes, there is histograms and plots, scatter plots, box plots, but you can really understand the inconsistencies. You can really understand, is it going to give me good model metrics? That's so powerful. There is something called Quick Model. It runs this data set, a few of the rows of the data through the model, and it will tell you what kind of metrics can you expect out of this, right? It also gives you feature importance, which feature is impacting the model more. And once you do all of that, so this is, imagine you are doing it in a small scale, you're trying out your code is ready. How do you put it in production? Wrangler gives you many options. You can push the data to S3. It actually spins up a processing job to use your transformations to the data that you have specified. Or it can do different things. It can push it onto SageMaker pipelines. It can even use frameworks like Kubeflow, if you know. These are the pipelines that you can use for machine learning. Now, just how it looks, you will use the studio in the lab. I encourage you to just play around. So here we are seeing how you can configure different data sources and bring that data in. And how can you easily transform? And look at the right side here. There are so many transformations available. And also, if you see here, custom transform, you can write your code here and add it to the list of transformations. And then the plots, right? We love the plots. We want to see the data distribution. We want to see correlation. But the biggest strength is estimating model accuracy. It can tell you which features are more important for the model. And this is really powerful because you have it at the tips of your hand. You're not going out of this data preparation step, but you're able to really test out your model. Imagine that you've not deployed your model, you've not done any of that, but this is able to do it, which is amazing. And how do you put it into production? As I already said, there's pipelines. You can push it into feature store, and you can spin up. It can push it into code or notebook, and it can spin up the processing job to process your data and store it finally in S3 or feature store. Well, as we've already seen, there are many services to explore your data. There's Notebook itself. If you're really good in Python scripting, you can use NumPys, Pandas, you can use Matplotlib. So it gives you really, Notebook is powerful. I don't deny that at all. But if you want quick drag and drop, less code, I think Studio is great. Then you have Apache Spark. As I said, if you are a Spark shop and you already have an EMR cluster, yes, SageMaker gives you Spark SDK that you can connect to SageMaker and leverage that infrastructure. You can use your console or you can use your own device. Maybe you want to put a script on EC2. That's fine too. Okay, ground truth. I think majority of the data models or algorithms need labeled data. And we have seen that this is a very manual process of labeling. It could be very high cost, a lot of effort spent in this. Right? For example, if you want to build a computer vision, that's what this is trying to say. You have to look at like hours and hours of video streams and maybe millions and millions of frames and really try to identify these different objects, right? Stop signs and pedestrians and things like that. So this can get really expensive really soon for any company. Now, what ground truth does is it uses something called mechanical Turk. So this was a standalone service before. I think it's still available, wherein you can get labelers to label your data. You can even get your own approved vendors, or you can go to marketplace. And these labelers are looking at your data. You give them a workflow, and they're going to follow that and label your data. But that's okay. That anybody can do. So what is special about ground truth? There is machine learning in this, right? So this model continuously learns from these labels. So once the humans label it, it's given back to the automatic annotation, which is a machine learning, and it keeps learning. And at some point, it builds a high confidence, and it takes over, and it starts labeling your data. And till the time it has low confidence, it keeps learning from this humans generating your labels. This we have seen has reduced the cost tremendously, the timelines tremendously for customers. Okay, moving on to next. There's a lot of content. We will go through it. I hope people are still attentive and enjoying it. And after this, we'll have a lab so you can test out a lot of these. What is feature store, right? Some terms that we want to get familiar with. We have raw data, right? data coming from these different sources. Then we have something called feature. Features are really signals from this raw data. What are those that we really want to use for a machine learning problem? We are always striving to generalize. We don't want machine learning model to memorize, right? It really learns very, very good from the training data and overfits. We don't want that. So we really have to select the features. That's why we have feature engineering, right? So now, if you look at a single entity, maybe you take a tuple of the gender, driver characteristics, vehicle characteristics, you associate with other structured data that has come in, that is a feature vector which uniquely identifies an entity within that data, right? Now, when you determine the logic to convert this into data that you want for machine learning is called feature engineering, but the actual act of doing that is what is feature processing. Now, let's take a look at what happens without this feature store that I'm talking so much about. We have these different data sources, vehicle damage, telemetry data, and let's say there is a team in the company that's building this vehicle total loss model. It looks at all of this data, builds a pipeline, does feature engineering, transformation, stores it, uses it. Awesome, model works perfect. Now another team wants to build a customer churn. It needs 3 data sources. It builds its own pipeline, uses it, model is perfect. But do you see what's going on? It's a sprawl. Maybe there are common features across all this, but we are not utilizing this because those features are within those models. You're not storing it in a central location. So every team is doing this. There's huge complexity at this point, and then there's huge cost, time wasted. So what feature store does is you have the same data, the same logic is applied, right? You are generating features from these, but it eliminates redundancy. So you have this central storage where teams are able to search, you can reuse features, and you have different kinds of storage within feature store that I'll go through very soon. And now everybody in the organization is able to use this. There is no sprawl, very clean pipelines, and reusability. Now, feature store, you're processed, you store it in the feature store, right? There are 2 kinds of feature stores, online and offline. Online, think of it as a latest snapshot of your feature. Very low latency, still high throughput, maybe for real-time inference. Offline feature store, think of it as it has historical features, everything that you can think of. You can use it for batch transformation or even for model training. You can feed that back. Now, the way to put things in feature store is through using API. There is a put record API, and you can use it through streaming. Maybe there is streaming data coming in. You can use streaming services like Kafka, Kinesis, or you really want to do it as a batch process, right? So the difference between these two, as I already covered, is real-time batch, right? Because if you see the offline feature store, you have a consistent read after write consistency, although less than 50 minutes, but it is some. But here you're getting millisecond latency. So how does it look? Some screenshots. So really the way you do it is you create something called feature groups. And feature group you can think of as a logical collection of parameters and compute that you have used to create that group. And the other teams can reuse these feature groups for their model, however it's applicable. And there is easy search, browse. You're able to see what all the teams have created and what can you reuse. I talked about it a little bit about storage, and there's lots of metadata. If you look at this, there's so much information available, which gives you more information of what this feature store is about, right? Okay, clarify. So bias is I think a problem, and bias can be introduced in many different ways. Let's take, for example, you have a biased data. Maybe it's biased towards younger people, the age demographic, and then once the bias enters a data set, it is going through every layer, right? It is hitting the model, and that exacerbates the problem. Right now, your model is biased. So it's very important to detect bias, and it's a complex problem, right? You may have a lot of manual things to do, and you may have to use different tools to detect bias, right? There are a lot of open source packages that lets you do this. You might have to write custom code, and it's really complex. Right? Bias has not been at our fingertips. Just to detect bias, it was really hard. So what AWS did was introduce this Clarify. It's an end-to-end solution for detecting bias, not just in the data, not just in the pre-processing step, but all through the lifecycle. Training your model, you've deployed your model, right? And then you are actually monitoring it in real world and trying to see if there is any drift. So how does it do this? There's tons of things Clarify is integrated with. So Clarify itself is a service that detects bias, but how can you leverage this in different steps? When you talk about data pre-processing, the Clarify is integrated with Data Wrangler. Let's say you're using Data Wrangler for data prep, and Clarify is integrated, and it can give you bias statistics. It can actually give you graphs. Once you use a studio, you will see that as you use Data Wrangler, right? And then now you have eliminated bias. You are training your model. You have your trained model, but you want to check for bias in the model, and that happens through something called SageMaker experiments. And Clarify is integrated with it. It checks for bias, and it provides you like a visual report of what is going on. And then, okay, you've trained your model. You really want to understand your model, right? What features are impacting this bias? And again, experiments gives you that capability. So even after your model has been trained, you can really get all those stats from your trained model. Okay, your model has been deployed, you're making predictions. Now you can use Clarify again with experiments to really understand how each individual prediction is made, right? I mean, imagine this. It's not a black box. You can really understand. It's so transparent. And once you put it in the real world, there are a lot of real world factors that might affect your model, right? Maybe the mortgage rates have changed and it's impacting your model. So Model Monitor, another service, lets you monitor the drift. And once Clarify is integrated with it, it can actually alert using things like CloudWatch that there is a bias drift also, and we need to take action on it. So Clarify itself and the integration with these different sources, different services, gives us ability to detect bias in every step. Once you detect bias, you have the ammunition to mitigate it, right? So just to recap, I think bias is, we all have seen, it's very important. We have seen how bias has created a lot of problems, especially if you think about real estate. So this really helps. You are doing it in data preparation, training, deploying, monitoring, just recapping how you can use it in different parts of the life cycle. Just how it looks within Studio, different bias metrics that it captures, explainability, right? How is your model really working? What are the features that's impacting? Even when it goes in the real world, I get a prediction, and how do I explain this prediction, right? It's for compliance, it's for transparency, it's for when a customer calls and says, hey, why did you deny my loan application, right? And behavior, it explains the behavior. I know screenshots you cannot read, it's fine, it's just to show. Just play with the Studio once you get access after this session. And all the graphs that it shows and relative feature importance that it shows. Just to put everything back, We looked at the preparation phase. We saw how SageMaker is so powerful. We dove into data Wrangler, how it can really help you in preparing data. It's like a one-stop shop for so many things. I love it. Processing, powerful distributed processing service that we have. We looked at feature store, we looked at clarify, and also ground truth that can help in labeling, right? That's the end of this session, and I really hope it was useful. And if you look at the webinar app, there is a handout section, and there are a few slides out of this that talks about it. So please download it and look at it. It talks about the ML stack and some of these services. And always this recording is available. So if you ever want to go back and check, it's a great way to just listen to my voice again. Okay, so what we are going to do next is do a lab. We are going to use the SageMaker Studio, and we are going to do some feature engineering. The lab instructor will take you through that. There are a couple of options how you could do that. I think today we are going to focus on using SageMaker Notebook, NumPys and Pandas, and it is great. Studio is awesome, but you know, spinning up a notebook inside Studio and able to code so much. If you're a developer, you'll really enjoy that. That will happen in the next 1 hour, and then we are going to have a break. So in order to use this lab, we have sandbox environment, and I am going to put the link on the chat. Can somebody confirm that chat is still working? I was not able to see anybody's answer. I don't know if people answered, but I can put it on chat, and please take the link, and the instructor will walk you through how to go about accessing the sandbox environments. Thank you all.
And after that, we will be in the AWS Management Console here. In the search bar above, you need to click on it basically and write SageMaker in order to get access to the SageMaker service. By the way, is anyone like having troubles or questions about like how we got there? Maybe your email didn't come or what? Yeah, please let us know. And basically, you need to press SageMaker Studio button here. After that, you will have like this SageMaker Studio control panel with already existing user, SageMaker user. And in order to enter the Jupyter notebook provisioned by SageMaker Studio, you need to click here, open the studio. It will take some time to spin up an instance, and after all, you'll get this kind of dashboard, or maybe I can show you here. Yep, something like that. But it will be empty, of course. Okay, so after that, you'll need to press Notebook and Compute Instances here in order to select Data Science SageMaker image and press on the Notebook button. Like that. So as you can see, like Get Started window, select Data Science image, and press Notebook. And you'll have like an empty notebook after that, which can be renamed, for example, as Immersion Day IPNB, like right click on the step, rename Immersion Day, or like you can leave it as is. And the next essential step is basically we need to get the source codes for the Jupyter notebooks, and we can do that by pressing this button here, terminal button. After clicking that, we will get access to our terminal session. And from the on the guides here, we need to copy this command, basically git clone and URL to our source codes. I will share this command in chat just in case. And after executing the command, basically, something like that will appear. And to the left, you will see a folder, which, like, on clicking, will reveal its contents. And we need this XGBoost Direct Marketing SageMaker notebook. If you guys can open this notebook and didn't encounter any problems, please leave a plus. Or if you guys encounter some kind of like errors, please let us know. I guess we can wait a bit for other people to complete this. Okay, so yeah, again, like you need to open the SageMaker Studio here. You'll see a control panel. After that, you click Open Studio, like that. Wait a bit. And create a new notebook from this get started page. Make sure that the image is data science. You click here on Notebook Python 3. After that, in this notebook, it will look like this. You need to press a terminal button here. And then you clone the repository, and I shared the command in chat to do it. Just close this windows. Okay, so let's move on. So this is like the notebook which will be used in today's session. It consists of different sections. First of all, let's get into the background of the problem here. So our company is a direct marketing company, and we want to predict if a consumer will enroll for a term deposit at bank after one or more calls. So basically what we have here, it's a data set of customers' features like demographic, historical interactions, etc. And our target variable, it's will a customer enroll after for a term deposit at bank? So here you can find like more elaborated version of background, and let's get started. So first of all, we need to prepare our environment. We need to execute this command update pandas up. Sorry, yep. We also need to kernel. If someone like is having the same problem as me, you need to click the no kernel here and select the data science kernel here. After some time, it will be ready to go. You can execute these cells by pressing Shift and Enter or Return on macOS. So as you can see, I execute this cell and it updates my pandas dependency. And let's take a look at the next cell. So here we have like this is the output of the command. So let's just ignore it. Everything is going fine. So the next cell, it's prerequisites for SageMaker SDK. Here we specify what kind of bucket we want to use. It's just like the default bucket with random name for the current session. And in this is the prefix which will be used for objects inside this bucket. And we get execution role for IAM for further SageMaker executions like training jobs, etc. So let's run this. And as you can see here, we have a list of different libraries. We use like the NumPy and Pandas to manipulate data, Matplotlib to show it, some IPython helpers to show like these beautiful tables and images. Standard library, SageMaker ADK. Nothing exotic. And let's make sure that our Pandas version is 1.2.4 or later. If you have any troubles executing cells, please let us know. I guess nobody's having troubles with that, right? So I don't see any issues here. Or maybe if I'm too fast, guys, let me know. I will just maybe like explain some things slower. Or if you have troubles executing cells, opening the notebook, etc. Okay, let's carry on. So here, after the initialization, we have this data segment, right? So here we will just use wget to download an archive locally, and we will use the zip file to unpack this archive. This archive actually contains CSV file, which we will open using pandas. So let me just execute this cell. And here we can see, okay, yep, sure. Here we can see the data frame, like basically pandas read our CSV file and created a tabular object which we can work with in order to explore our data. Okay, I guess there are no issues for now. It's working now, cool. And like while we wait, let's just talk about data. What can we see here? So we can see almost 40,000 customer records, 20 features. We have a mix of categorical and numerical features. And yeah, as mentioned here, data appears to be sorted, at least by time and content, maybe more. And we have different groups of features. For example, here we can see features related to demographics like age, job, mental status, education, past customer events, past marketing contacts, and campaign information. And here we can see description which features are numeric, categorical, and some possible values for them. Yeah, there's also like external environment factors and our target variable that we need to predict. Why? Has the client subscribed to a term deposit? Binary, yes or no? So this leads us to a classical classification problem, which we will tackle right on. First of all, we need to explore our database, basically. Yep. So here we have a snippet of code. What it does is that it creates frequency tables for categorical features and histograms for numerical features. And it can take some time, but here we are. It is ready, basically. So a little bit magic is happening here. So by using this code, basically, we select only features from the table which have type object. What does type object mean? Type object basically in pandas terms is a string, some kind of string value. Since here we have like numerical and categorical. Numerical values are float and categorical values are a string. So we assume that it's safe to use object here to extract categorical values. Yeah, and as you can see here, there is a frequency diagram. So for each categorical value, we can see the frequency, how it occurs in our data set. So for example, here's like a job feature, status feature, education feature, default feature, housing, loan, contact, like telephone, yep, month, the week, and every row here represents some kind of value that was found in the data set. And to the right, like percent of the observations. So basically this is like 6%, almost like 15%, almost 0%. Here we can see like the description of this data using built-in pandas tool, which can say some kind of like statistics about our values. Mostly it applies to numerical values, like count, mean, percentiles, maximum value, minimum value. And here we plotted the histogram of our numerical values. And as we can see here, our data is not ideal. Basically, for example, if we take a look at our target classes, yeah, I lost it. Where is it? Yeah, Y. So here, like Y, it's like frequencies of our target variable. And as you can see here, 88% of the data, almost 89% of the data has no label. And only 11% of the data has yes label. So it means like our classes are unbalanced. So we need to keep that in mind. Also, we encountered some unknown categories, like values for category, for example, here in loan, housing. So basically, it is safe that assume it can be represented as a separate category, but still in real life, it can just, like some of the unknown values can be actually be no or yes. So yeah, we'll need to keep that in mind also, like how to manage this missing data. Also, some of the features have very few observations, like as we mentioned here, for example, December, month December, it's almost 0% of the data. And the data actually, yeah, is partially skewed. As we talked about December, also we can see in histogram the variable p days here. It's consisted mostly of the values of 1000, which is quite interesting. It could be just a placeholder, it could be just an incorrect data, so we also need to take care of that, maybe like keeping that in mind. We need to somehow handle it. And like that's the basic overview of our features. Let's dig deeper. So here, the next cell, we want to find out how our features relate to the target variable that we are trying to predict. Using the same pandas magic, include object, exclude object, we create a different views for our categorical and numerical data. So basically what happens here is that we create a frequency table for each categorical feature. And for numerical features, we just plot histograms again. Yeah. But it gives us some kind of like overview of how our feature relates to some kind of specific value of our target variable. Yep, here we can see tables for categorical features, and there are the plots for numerical ones. And as we can see here, the data is also like proven to be not ideal. For example, values for blue color, married, unknown, and contacted by telephone in May are substantially lower portion of yes than no for subscribing. Let's take a look at that. So take a look at the blue color variable here. it is a categorical value. I believe it's a job, the color. Yep. So so we have types of job with yes values prevailing. And for example, in blue color, there are no prevailing. So we also need to keep that in mind, basically. And we can compare the same distributions for numerical values. So as you can see here, how employment rate changes for no variable and yes variable. And as you can see here, for every numerical feature, distributions are different. So it doesn't mean anything at that point, but we can see like the data is different, but we can really jump to the conclusion that there is or there is not some kind of connection between these variables. So relationships is not obvious in that case. And so yeah, we discovered the relationships between features and target variable, but what about relationships between the features? So we want to compare them one to another. So for that, we create a correlation matrix and display it as scatter plot. It will take some time basically to show graphic here, but as we can see here, there's already a correlation matrix here. And as we can see, the range of correlation coefficients, it's very wide. So we have negative numbers, we have numbers close to 1. And sorry, it's really hard to make some kind of assumptions about that. So relationships between feature could be non-linear, or even in some cases, it could be discrete. And the plot is taking some time to render, basically. It happens. And while we wait, does anyone have any like problems, issues, questions about this notebook? Okay, sounds like no. Cool. So yeah, this is like the graphical representation of correlation matrix. And as you can see here, indeed, in some cases, the relationship is discrete. So we explored our data set. We discovered some kind of interesting facts, basically, about our data set. And I guess we are ready to move on with transformation. So after the data exploration, we need to prepare our data set so our machine learning training algorithm can consume it. This is like this transformation part. And during transformation, basically, we cover following things. For example, we need to handle missing values. We need to convert categorical features to numeric because like algorithms cannot just work with strings. They want input variables. We have all the distributed data, so we somehow need to eliminate that. And yeah, there could be also some kind of transformations for complicated data types, like for example, images, text, or data at running grains is left. Yeah, for other notebook templates, we do not cover that. Basically, our data is very simple, structured table. And in this cell, let me just execute it. Cool. So we create some kind of indicators. So we enrich our data set, adding additional data here. So we add this no previous contract field, and it means that P days, it's equal to 1999, 999 basically. Sorry, yeah. And this is an assumption that P days is actually a placeholder just to mark some kind of customers that are like old, maybe like they don't have interaction at all. So we assume that P days of a value 999 is like actually some kind of placeholder, and we create an additional feature which will describe exactly that. And we also enrich this data set with not working feature. It's a feature which consists just like comparison. If a job for a person is student, retired, and unemployed, then put 1, otherwise put 0. Just basic features here added. And we also need to perform one-hot encoding. So for example, we have categorical features of like student, job with value student, retired, and employed. So this code will actually transform this job feature into the job student, job retired, job unemployed using one-hot encoding technique. And so here we added some features. We transformed our categories into numerical values, and we want to see that our model doesn't really overfit or get trained on some kind of like ambiguous features, which are hard to predict in the future. For example, our dataset contains like fields like duration of the campaign. It contains data about employment rate, indexes, etc. So this data, while it's useful for historical data, it's not real. It's very hard to predict such kind of values if you are going to make our predictions to the future. So in that case, we just drop them because they just include additional noise, and we want to keep our data set as simple as possible. Execute that. Cool. After that, basically we prepared our data set, but there's one more thing to do. So there are concepts like overfitting in the machine learning, where model just learns some details about your training data set, and it overfits, it creates a bias toward that data set. And in reality, such kind of models, they don't really work. To fight this issue, basically people use different techniques, such as holdout validation, cross validation, leave one out validation, etc. For this lab, we just split our data into proportions. As described here, the model will be trained on 70% of the data. This trained data variable will contain that. Then it will be evaluated on 20% of the data. This is evaluation data, validation data. And we will hold back 10% of the data for further evaluation. So this is the variable test data. So this line of code basically just splits our data set into 3 data sets. Training data and validation data will be used for XGBoost training algorithm. So we need to save it, first of all, locally. We will run this cell. XGBoost expects data in libsvm format or CSV data format. For this lab, we use just like the simple CSV format. So yep, it was executed here. And now we need to upload this data into the S3. So SageMaker training expects that the data will be on S3 bucket. So we need to ensure that it is there. So we execute this snippet of code. So yeah, that's almost the end of the lab 1. If you have any questions or issues, please let us know. So yeah, there's the question. While dropping few features from the datasets, how do we select them? So basically, it's not only data from the correlation matrix or like this frequency diagram. It basically needs an insight from domain experts. So for example, we know that it's very hard to predict employment rate for the future or price indices for the future. And we know from our domain experts that like the duration of campaign, like given for a single user, it doesn't really matter. So combining all these facts, we decided to drop these following features because they are considered like too noisy or like not realistic to predict for the future. Yep, oops, spoilers, that's the second lab. So yep, assuming that you uploaded the data to S3, let's check it. So here on AWS console, in search bar, we can press S3. And there we will find SageMaker US East 1 and some kind of ID. That's the bucket where we store our data. Region like can be other. It's not like relevant here. We just need to find a bucket with SageMaker -region -ID. So if you click on that, we drop down to SageMaker prefix. Here we can find demo XGBoost DM prefix. And here we can find train and validation prefixes. So train prefix contains train CSV, the file which we uploaded just right now. You can see details such as size, etc. You can download locally. And the same is validation CSV. Like, yeah, it was uploaded. So overall, for the first lab, we extracted features, we deleted useless ones, we transformed our data, we split our data into 3 parts: train, validation, test data. And for SageMaker training job, we exported train data and validation data as CSV files on S3. And that's all. That's the end of the lab. If you have any questions, if you have feedback, please use questions or chat in GoToWebinar. And I guess in the agenda here, we'll have a break soon. And yeah, let's just maybe answer some questions here. Yeah, so there's like question, other than domain expert, can we use the feature process methods like the recursive feature selection or forward-backward method selection? And the forest feature importance also provides one option. Yep, totally agree, but like for the sake of this like lab exercise, we just wanted to keep it simple with some kind of predefined knowledge and like basic statistics here. Like nothing as cool as these methods, obviously, but like yeah, just like prepare basic data for the next part of the training to show the capabilities of the SageMaker.
Bulat, if I can add something, the lab instruction link is public. You can use it anytime, go through it. And there are other ways to do this. For example, there is a way to do it using Data Wrangler and push it into Feature Store. That's a great thing to test as well. So take some time. These sandbox environments will be live for a few more hours after the session ends. So feel free to play with it and feel free to use the lab documentation that's always available. Thank you.
Yeah, so yeah, I guess that's the end of the lab. I think we will still be available for the questions, feedback, etc. So feel free to leave it in the GoToWebinar chat and questions. And I think I'll just turn on my screen share and I will be here for you answering your questions. Thank you for your attention.
Okay. So hi everyone, my name is Rinat. I'm from Provectus. I will be leading the next session where we will explain how to build, train, and deploy machine learning models using SageMaker capabilities. Before we start, here's the brief overview of what this session includes. Yeah, we'll start with brief recap of the place of SageMaker among our Amazon Web Services that helps you to solve problems using machine learning. Then we will show how SageMaker can help you during model building phase. After that, we will talk about options that SageMaker provides to reduce the efforts dedicated to training your models from different points of view, like development, computational, and infrastructural. Next section will be about tuning hyperparameters of your models. After that, we will briefly cover SageMaker experiment management and experiment debugging. The next big session is dedicated to deployment and serving options for your model. And we will conclude this session with a few words about SageMaker Model Monitor. I will note here that this is not a complete list of all available SageMaker components. There are more that unfortunately we can't touch today since there is a time limitation. And just to name a few, like SageMaker Autopilot, SageMaker Neo, Elastic Inference, and one of my favorite, SageMaker Pipelines. Okay, so you probably remember that slide from the previous session. So SageMaker is in the middle layer. That means that it is more like a toolkit, like fully managed toolkit that can help you solve different machine learning problems and facilitate you like during different steps of machine learning process. Okay, so we mentioned that quite a few times today. SageMaker is a service with a lot of different features and capabilities in it. We typically talk about those capabilities as falling into 4 categories, like data preparation, which was covered during the previous session, and the remaining 4 I will cover right now. About model building, training and tuning, and deployment management or hosting of models. Yeah. These 4 categories really address the needs that most of machine learning builders have when dealing with each stage of machine learning model lifecycle. Okay, let's start with the first category about model building. Usually this phase includes several activities. First, choosing algorithms that is appropriate for your task, the one that you are going to start with. Then implementing it, or more often using existing implementation and adapting it for your task, data, and environment. And you also should keep in mind what will you do later if you want to improve the model or try another algorithm with minimum disruption. Here we suggest using SageMaker Studio or notebooks to get started with this part quickly. It is kind of pre-configured IDE, well integrated with our other services that we will talk about later. It also simplifies sharing and collaborating on that modeling and experimenting part with your colleagues. Okay, so at this stage, you usually have your dataset prepared and uploaded to S3. And you did that during the first practical session before. I hope all of you completed that part. So moving next, once the data is in S3 bucket, you need to choose an algorithm to train your model. And SageMaker provides you with the following options that differ in how much code and configuration is expected from you in order to make that work. The first option, use one of the algorithms with built-in implementations in SageMaker. In this case, no model coding is required. You just have to prepare data in a format and structure required by the chosen algorithm. If one of these fit your needs, it's a great out-of-box solution for quick model training, or at least it can lay foundation for strong baseline. So the second option, you can submit custom Python code that uses one of the popular deep learning frameworks like TensorFlow, PyTorch, or MXNet. This is usually called in SageMaker documentation as a script mode. It means that SageMaker manages pre-built containers for the most popular open source frameworks, solving a lot of dependency, resolving issues and environment setup problems. And you just have to provide one or more Python script files that define your model using your favorite framework. Next, the most flexible option, use your own custom algorithms. Put your code together as a Docker image, use whatever dependencies you want there, and specify the registry path to that image in SageMaker API calls for creating training jobs. Next feature, you can use an algorithm that you subscribe to from AWS Marketplace. Where you can browse and search for hundreds of machine learning algorithms from third-party vendors in a broad range of categories such as computer vision, natural language processing, video analysis, fraud detection, predictive analysis, and more. And in some cases, you can just start with SageMaker Autopilot. For example, if you have tabular data and you can specify one of the columns there as a regression or classification target, give it a try. Autopilot automates feature engineering and model search process and provides you visibility during that process. I mean, you can view data preprocessing and model parameters that Autopilot tried as a generated Jupyter notebooks. And you can use that as a baseline and later just use these notebooks and fix things that you don't like or you know how to improve as a domain expert. All right, so here is a brief overview of a few SageMaker pre-built algorithms. They are grouped by use case. SageMaker provides high-performance, scalable machine learning implementation of these algorithms, optimized for speed, scale, and accuracy, and they can perform training on petabyte-scale data sets. You can choose from supervised algorithms where correct answers are known during training, for example, XGBoost or logistic regression. And there are also algorithms that can help you with image processing and natural language processing tasks like blazing text or for problems that fall into time series, future value prediction, for example, demand forecasting or predictive maintenance. There is a deep AR algorithm. And SageMaker also includes support for unsupervised learning, such as k-means clustering or principal component analysis to solve problems like identifying customer groupings based on purchasing behavior. Also, feel free to share with us in the chat which use case or maybe which algorithm you already tried, currently working on. Maybe some suggestions of what built-in algorithms you also want to see here. All right, so this is now for modeling part. Let's go to the next section about training. Once we prepared data and selected, implemented or adapted an algorithm, how do we actually produce a model? So here we're not going to dive deep about mathematical foundations of training process. Instead we will focus on a contract between SageMaker and you to make that computation happen and what benefits SageMaker offers. Before we continue, I have a new question for audience. I'm curious to know where you train your models currently in your organization. So I will start the poll now. Yeah, so please select one or more answers from the list. Just a few more seconds. All right, I'm going to close the poll now and show the results. So I can see that not a lot of people use managed services for training machine learning models, and so I guess the next section can be helpful to fix that. And also almost half of the audience prefer training on local developer machines. Okay, I'm going to hide results now and return to slides. Okay, so let's continue. First of all, SageMaker supports several programming models, and not only for training, but also for other features that we will discuss. Yeah, so first, it's like about low level, like invoking low level AWS SDK API operations, and like create training job, and for example, Python SDK library called Boto3 for that. So the second option, using like high-level SageMaker Python SDK, and this SDK like provides you object-oriented wrappers that hide away many low-level API invocations and allows you to easily switch algorithms and parameters later. And one more, if you're a big fan of Spark, first of all, let us know in the chat about that. Maybe you are using like Spark on Amazon Elastic MapReduce, then you can use the SageMaker Spark library to launch your processing or training in SageMaker using like the same interfaces for our algorithms. So later it will like facilitate the transition or like trying different other algorithms for your tasks. All right, so let's walk through how the training process works in SageMaker. So the training job starts with provisioning a compute instance or several of them, so like cluster, and downloading a Docker image of your training algorithm from Amazon Elastic Container Registry. So when SageMaker sends your data sets from like S3 bucket and mount it into the Docker container, then it launches like train entry point of your Docker image. So you can treat it as like alternative to like model feed method. Yeah, once this entry point completes its execution, SageMaker writes all model artifacts to specified S3 location. All right, so let's see how can we use, for example, built-in, previously mentioned built-in algorithms. So for that, we need to retrieve the image URIs. So here you can see a code example using SageMaker SDK for extracting XGBoost image URI. Yeah, so just to answer maybe some frequently asked questions about pre-built algorithms, the code of built-in algorithms is not open source. Yeah, so you can see the code of that built-in containers, and you can modify it. But there are two exceptions, like blazing text and XGBoost. Both have artifacts that are interoperable with their open source equivalent. So, but if it's a big obstacle for you, so remember that there is also like two other options. You can either bring your own script or bring your own container for SageMaker. All right, so here's an example of how you can train model with a built-in algorithm using SageMaker SDK. So yeah, we can, I guess many of you can see some similarities to scikit-learn API. And here's a more complete example with XGBoost, something that you is going to try in during the next practical session. Yeah, so in the first two lines, we specify what we call like input channels for training job. So you can see these input channels are algorithm dependent, so always check like algorithm specification or documentation about which channels is required and which are optional. So for example, for built-in XGBoost, train channel is required and validation is optional. Yeah, then the next important thing about SageMaker session instance. So SageMaker session is kind of high-level convenient wrapper that abstracts away like identity that that SDK will use to actually call like low-level API operations and few other like default configuration, like default region or default S3 bucket. And this is actually really useful because in quite a few places, when you're using SDK, you can omit specify an exact path for output. And if you don't specify that, in many cases, SDK will generate that output path just using this default bucket, like image, URI, and current timestamp. So just to make code less cumbersome. All right, so let's see. Here we can see how can we specify, like how can we configure resources like compute instances that we want to use to launch training jobs. So I guess like self-explanatory, like train instance count and train instance type. Yeah, about train volume size. Volumes are attached into each training instance, and they are used for several things. So first of all, they should be able to contain like output artifacts like serialized model weights, then maybe some incremental states like checkpoints, and in some cases they will also contain like input training data set. So make sure that size of these volumes is enough. All right, so one more important thing here about role. So role parameter, it specifies execution like service role for SageMaker instance that will run Docker container with your like training script. Yeah, so just basically should allow like have permissions for that. So maybe your like training job requires like accessing S3 buckets outside of usual logic, or like maybe it calls some other services, things like that. Yeah, and also I guess it should be enabled by default when you use SDK and call feed method on estimator. Logs are enabled by default, but you can because regardless whether you use SDK or not, each training job produces logs, and they are collected by CloudWatch service. So if you can always fetch that either using SageMaker console or using SDK. All right. So about so currently there are quite a few options. How can you feed data into your training jobs? So we will start with S3. However, there is also like a different option using like EFS volumes for training jobs, and also you can specify like kind of data set definitions using Athena, Redshift, or even like the newest one, is integration with Snowflake for data Wrangler or processing jobs. Yeah. So but here I will just briefly explain how can you do that for S3. So SageMaker training jobs support two modes, either file mode or pipe mode. So file mode just copies the data set from S3 to training instances. Yeah, so that's why you need to provision enough storage using this volume size parameter. Yeah, and if you specify that you want to launch like several instances, several compute instances, you can also specify how you want SageMaker distribute that data, either like replicate entire data set for each instance, or you can specify that it can be just partitioned by like object keys in S3. Yeah, and here for file mode, actually data format is not that important because files are just copied, but you should also check algorithm documentation for that, obviously. Yeah, and then pipe mode does not copy your data set. It streams it into training instances. So this allows you to process like very huge data sets. And because it does not copy files before actual training script run, the training starts faster. Yeah, so and you could enable that mode for your like custom algorithm by some additional coding, but many of built-in algorithms already support that, as well as pre-built TensorFlow image, for example. Yeah, and in this case, data format should be record IO protobuf. All right, so in one, like also answering like frequently asked question, like every training job runs on a like ephemeral cluster of EC2 instances. And this means that You can't see that EC2 instances if you go into like EC2 console, because it's fully managed by SageMaker. So SageMaker just like takes care for everything, like provisioning them and shutting them down immediately once a training job completes. All right, so now we're moving to the next section that is dedicated for model tuning, and meaning how we can use SageMaker to tune hyperparameters. And here's just a quick recap of theory. So you create a machine learning model to make predictions for solving a particular use case, such as like predicting fraud, for example. And in order for model to predict well, like for new data points or unseen requests, it must not either overfit or underfit. So and to avoid these cases like overfitting or underfitting, you need to understand first of all use case correctly, your like business domain, and then also like balance between model complexity and data availability. So just a quick recap, I guess many of you already knows that. So overfitting is a situation when there is not enough data to learn from, and the model is way too complex. Yeah. So as a result, model does not generalize and makes poor predictions for unseen requests, but it might seem like it makes good predictions for data points used in training set. Yeah. And underfitting is when you have a lot of data, but model algorithm is not complex enough to learn from large amount of data. As a result, model does not generalize and makes poor predictions. Okay, next slide. Here's just a like different visualization of what's going on during underfitting or overfitting. So in the left, you can see underfitting. It means like model is way too simple to just like decision boundary is represented as a like just a straight line, so just two parameters for that. In the middle we can see overfitting case. So in this case like a lot of curves, so probably a lot of parameters that model should train, but so model just picks will not generalize well because it just picks up the noise instead of trying to like generalize and understand underlying relationship and patterns. Yeah, so in this you will see like good scores on training and bad on like validation of test data. Yeah, so well, when I talked about like model complexity, usually it can be regulated using like hyperparameters. So for example, in this slide, you can see examples. So like picking like right amount for like 3 devs or like max leaf nodes in case of random forest classifiers or regressors, or in case of neural networks, you can choose like model complexity with a lot of hyperparameters like number of layers, like and number of units in hidden layers, like different regularization techniques like dropout. So yeah, basically when you're tuning your model to be more accurate, so there are 2 big levers to pull. The first lever is data. So you can try to modify data set, get more data, try to enrich it, augment it, or maybe generate more features. So, and the second lever that is focus of this section is like parameters that define like model behavior and more importantly model complexity. These are called hyperparameters. And finding the right values for them can be difficult. So typically you'll start with something random and iterate through adjustments as you begin to see what effect the changes have. It can be a long cycle depending on how many hyperparameters your model has. And this is where Amazon SageMaker makes this easy by offering automatic model tuning as an option during training. So automatic model tuning uses machine learning to quickly tune your model to be as accurate as possible. So this capability lets you skip the tedious trial and error process of manually adjusting hyperparameters. Instead, the tuner performs hyperparameter optimization over multiple training runs by discovering patterns in relationships between hyperparameter values and objective matter. And this way you can save days or even weeks of time spent maximizing the quality of your trained model. All right, let's see how it works on practice. So how can we set up hyperparameter tuning job in SageMaker? So there are three major components in its configuration. So first of all, we have to define objective metric, like our goal. What do we want to minimize or maximize? Second, hyperparameter ranges. So and these ranges define our kind of search space for different hypotheses that the tuner should try. For example, suppose that you want to solve a binary classification problem on a marketing dataset using XGBoost. And here, as an objective metric, you can specify a metric known as area under the curve. So, and about hyperparameter ranges, you might just don't know yet which values like ETA, alpha, minimum child weight, and maximum depth hyperparameters to use to train the best model. So you can just specify feasible ranges for that, and SageMaker Tuner will search for the best combination of values according to the specified metric. And the third component of tuner configuration that's called here job specification. It includes, for example, how many trials is allowed to perform, how many training jobs the tuner is allowed to run in parallel, and also basic configuration for nested training jobs. For example, some hyperparameters might remain static across all trials. You don't want to, maybe you don't want to try to optimize all of them. All right, and let's see how it works behind the scene. When you launch hyperparameter training job, and in SageMaker SDK, you do that by invoking fit method and specifying the same input channels just as you would do for the usual training job for the same algorithm. So, and this is very convenient. So hyperparameter tuner can be used as a drop-in replacement for estimator or for single training job, because they share the same input and output contract. You provide the same input, and as a result, you will, in case of hyperparameter tuner, you will get the best model artifacts and metadata. So let's see how it works. So after you invoked fit method, SageMaker creates first round of training jobs, each with different hyperparameter values, this time with initial random guesses. Yeah, just as with training jobs, it sends and mounts data for all of these training job containers, and then it runs actual training algorithm inside each. Once it completes, it collects objective metric values from each training job and sends it into SageMaker managed Bayesian optimizer that uses that information to propose next hyperparameter value combination for the next optimization round. Yeah. So and now the second round begins. New set of training jobs are launched using new hyperparameter values, and the usual workflow for training jobs are repeated, like injecting data set and so on. And there are several criteria possible to specify, like to stop optimization and like complete the tuning job. So first, you can specify like a maximum number of training jobs, and this is like a required configuration option. And the second, you can specify like target value of objective metric. So once it's reached, SageMaker will terminate hyperparameter tuning job. And third, there is also option like early stopping. And if you enable it and subsequent jobs do not improve significantly, SageMaker will also terminate tuning job. Okay, let's see how we can plot that. So in total, we're going to walk through a large number of jobs. And when you get to the end of this, we'll actually get a like graph that's going to help us analyze it. So down that horizontal like x-axis, we have time in seconds, and y-axis, that's just your like metric value. And so for that first period, SageMaker initializing those three training jobs, again, under one umbrella, tuning jobs. And we're going to pull that objective criteria out. So we're looking at that objective metric. In this example, it's area and the curve. And we are going to reinitialize 3 more models. And hopefully for next rounds, that like maximum value of objective metrics is going to be slightly higher for each round. And Bayesian optimizer, it's going to be able to buff, explore, and maximize based on what it just learned. So it's going to be looking for multiple areas in hypothesis space until it ultimately finds the best model. Yes, and so that's how we actually get to those 7 full rounds. So in this case, we actually trained 20 models totals and found the ultimate best one. So a reasonable question here, what if I need all my jobs tuned at the same time? And good news for you is that we have like random search strategy, which is alternative for Bayesian search. So you can see like on the left side how Bayesian optimizer worked, and we just explored that in the previous slide. So in case of Bayesian optimizer, you have to wait until that entire process is finished, until the performance on your model has stopped increasing. Yeah, but over there on the right-hand side, also got random search. So just explicitly specified like a strategy parameter to be random. Yeah, and unsurprisingly, results will be random. And but the important thing that it's going to be able to do that all at the same time. So there's no need to for optimizer to make rounds. SageMaker can spawn all training jobs in parallel and just and after that just pick the best one. So if you got a use case where you'll need to find the best model and you have not much time, maybe half an hour to do it right, so you can try thousands of different hyperparameter settings with random search, and in half an hour, depending on the training job duration, you will get something maybe really promising model. So, like summarizing, in random search strategy, choice of hyperparameter values does not depend on the result of a previous round of like previous training jobs. You can run like the maximum number of concurrent training jobs without affecting like the performance of the search. Okay, let's see how can we do that in code. So yeah, just first we specify these hyperparameter ranges using like SDK classes, and SageMaker automatic model tuner supports several types like categorical parameters, continuous, or like integer. Yeah, and for integer and continuous parameters, you can also like choose the scale, like linear or logarithmic, or just leave it as is, like specify like auto value, which means that SageMaker will choose the best scale. Yeah, so when you specify like objective metric name, it can be like for each built-in algorithm, for example, you can see a list of available metrics in the documentation. And for your custom algorithms, you can fetch metrics using like regular expression that your training scripts outputs into logs. Yeah, so you can use like custom metrics as well. Yeah. So as you can see, just I want to emphasize that that's basically almost the same contract. So you can, if you started using estimator like single training job, later you can switch to like hyperparameter tuning without changing much of the existing code base. Yeah, and again, like frequently asked question, can you use automatic model tuners like SageMaker automatic tuner with your own models? And answer like definitely yes. Like there's no dependencies. So SageMaker automatic model tuner, like basically it treats specified model like as a black box. So no problem here. I mean, you can either like bring your own script or bring your own container and use it. All right, let me check time here. Okay, so yeah, this is it for training part. So now it's just a very quick review of experiment management. So as you know, machine learning is a highly iterative process. During the course of single project, data scientists or machine learning engineers routinely train thousands of different models in search for like maximum accuracy, for example. Yeah, and indeed, like the numbers of combinations for algorithms, data sets, and hyperparameters is huge. And that causes the challenges of finding a needle in a haystack in quite a few use cases. So I can provide a few. So for example, imagine you want to analyze side by side like outputs of two experiments where one of them might be done a week ago. And since that time, you already have like dozens of folders and files with like training job outputs and metrics. So in best case scenario, maybe you introduce some like convention for naming like timestamps, but you might miss documentations or comments or for them about what you actually tried back then. Like, have you fixed pre-processing back? Have you excluded a few more columns? Have you deduplicated data? And things can get even worse. Maybe you actually fixed things, but forget to push that code or rebuild your Docker image. This can happen like quite often. And now you're in some uncertainty about, can you actually trust that artifacts and metrics from the past runs? And in our use case, like during the experimentation, you try like different things. You modify data set, modify model or algorithm, And sometimes it might be hard to infer what is the main cause of improvement. And in order to do that, you might want to reproduce some of the previous experiments, like where setup is more similar to a new experiment, and make conclusions from comparing them. So before I go to SageMaker experiments, I want to ask a related question. So I'm curious to know, how do you manage and track machine learning experiments in your organization? Yeah, I will start a poll now. Please, yeah, it should be started. Please select one or more answers. So, and I don't see our answers yet, but if you do it like any other way not mentioned here, feel free to put that into chat. We are very curious about different approaches to tracking and managing experiments. All right, so I'm going to close the poll and share results. All right, so the majority of audience do not track experiments yet, and I see like quite a few already integrating experiment tracking tools. All right, so that's why you should give a try for SageMaker experiments. And the good thing that it's well integrated into all other components. So yeah, I'm going to hide results and return to sharing. Yeah, so Amazon SageMaker has a dedicated component, and not surprised, it's called SageMaker Experiments. So it lets you launch, track, compare, and evaluate thousands of model training experiments and model versions to quickly identify best performing models, and also help you with use cases that I mentioned previously. It automatically manages all the experiments performed by developers, and all machine learning artifacts like data sets, algorithms, parameters, model metrics are automatically tracked and recorded. And in order to enable that, you simply need to add a couple more parameters into training or processing job definitions, and just like experiment name, trial name, and the component of a trial that this job is responsible for. All right, we don't have much time left, so here is just an example how SageMaker experiments looks like inside SageMaker Studio. So you can track thousands of training experiments to understand the accuracy of your model. For example, here a chart of how different time series datasets impact model accuracy is shown. All right, so I guess I have to skip part about debugging. Yeah. So yeah, just a short break. I want to drink water. All right, so now we're going to the next section about model deployment. So unless you are doing research on the project, eventually, once you are satisfied with trained model quality. Most likely, you want it to be actually useful and make predictions for new data points and make its users or clients happier. And in order to do that, you will make decisions on where you are going to deploy it, like about infrastructure, about the model lifecycle, how like it will be managed and by whom, how requests to model are represented, and how they should be processed in order to pass it into predict method of a model instance, because most of the framework like do not work with like HTTP requests, like and a lot of more issues here, and more like challenging questions here, like how you will update the model, ensuring that endpoint for user is always available and like meets its SLAs, and how you can roll back that if something goes wrong with new versions. And now I have a new related question for audience. So I'm curious to know how you deploy your machine learning models in your organization currently. Yeah, I'm going to launch the, I guess it's the latest poll for today. Yeah, so please select one or more answers from the following. And unfortunately, I mean, for this question, it's more relevant. GoToWebinar does not allow you to put more than 5 answer items. So if you can find your answer here, feel free to share it with us in the chat. All right, I will give it a few more seconds. All right, I'm going to close the poll now and share the results. So at least a third of the audience do not deploy models currently. So I guess the next section should be helpful, but for ours as well, just to understand like alternatives and SageMaker, which SageMaker benefits. All right, I will hide results now and return to sharing. Let me do it. All right. Again, so there are like two main approaches, like two main options that SageMaker supports for model deployment. So first of all, you can use like hosting service when SageMaker like provision like compute instances and deploy your model there and provide like secure REST API endpoints. So, and you can share that endpoints like with your customers or your applications for real-time predictions. And another option here, which is called like batch transform. And in this case, SageMaker like provision like non-persistent like batch cluster to make predictions like across like entire input data set. So we will cover that in depth shortly. Yeah, and also if for some reason you like don't want to use SageMaker capabilities here, so but you have, for example, either your own custom Docker image or like AWS manages like highly optimized deep learning containers, you can use that and deploy using other Amazon Web Services for that, like ECS, like EKS or Fargate. Yeah, and the last option, like the most flexible here. So I mean, your model artifacts, they belong to you. You can use it any other way. You can just pull that from S3 and do whatever you want with them. All right, so let's. This is like conceptual high-level overview of what is like underneath like real-time endpoint. So SageMaker provides like HTTPS inference endpoint and like cluster of, or maybe single instance of like SageMaker instances for that. Yeah, and SageMaker like provision them in like different availability zones to like ensure high availability. And in the middle of that, there is like built-in load balancer that can be used to implement a lot of like highly demanded features. So you can like deploy different model variants on your for your endpoint, like, and make things like A/B testing or like canary testing. Yeah, and also there is like different option like for hosting like several models inside single container. Yeah, just a quick overview. That's something that you will try during the next practical session. So during the training, the section, I briefly mentioned like this estimator class. So once you call it its fit method and the corresponding training job completes, you can like get model instance from there. And model here means like package. Basically, it's just a combination of your model artifacts and some metadata, like which image you write should be used to make that, to deploy that model, and also any other metadata, like which training job produced that model and things like that. Yeah, and you can use that model instance in SageMaker SDK to quickly deploy a real-time endpoint just with a single line of code. So just use like deploy method for that. Yeah, and this is it. So, and for clients, you can create a predictor instance and configure it for that endpoint and use like its predict method there. All right, so not much time left for now. So I will just briefly go through other capabilities here. So real-time endpoints, there's like the built-in support for auto-scaling. So you can yeah, I've been disconnected. So can someone hear me?
Yes, we can.
Yeah, sorry for that. So yeah, I guess I have to go to the last slides to wrap up that. Yeah. So So, like supposed takeaways from this session, we talked about like quite a few different steps in typical machine learning process, starting like from building. And here we discovered that SageMaker does not, the most important thing here, that SageMaker does not restrict you to use like built-in algorithms, because it's like common misunderstanding. You can use almost all of SageMaker capabilities with either your own scripts or your own containers for your like custom models. Yeah, and for train, SageMaker takes care for resource provisioning in scalable and cost-efficient manner. Like for tune, you can like launch hyperparameter tuning with just a few clicks, or like just as like a drop-in replacement using hyperparameter tuner class instead of estimator. There is also like experiment management integration, which also can be enabled just a little configuration and few like lines of code. Yeah, and so, and for deployment, like there are several benefits. So first of all, you avoid some like boilerplate code, like to serve model, to deploy that. You don't need to write some like wrappers. Yeah, if you if your container complies to SageMaker contract, so you can easily use it just to quickly make like real-time endpoint, or use it in like batch processing jobs. Yeah, and unfortunately we didn't have much time to cover like the debugging, SageMaker debugger and SageMaker model monitor. Yeah, and many other things. So now just wanted to quickly mention about the scope of the next lab, because we, at least I tried to cover like a lot of capabilities, but in the next lab you will try training jobs, deployment in real time, and like also, if you have time, optional. So it's optional, like running hyperparameter model tuning. So, and with this said, I guess we have, according to agenda, it's a lunch break, right? So yeah. So yeah, so I guess we will go the following way. If there is a questions. Yeah, I can answer a few questions from the chat. Anyway, feel free to take your lunch break and return for exciting practical session.
So let's continue second lab. Let's continue our presentations. So thank you very much for previous speakers. They describe very deeply how SageMaker works, what we will, all parts of that we will work on a second lab, as well as with what we will work, what the data it is, how we, what the features, how we interact, make a feature selection, so on and so forth. So second lab will be continuation of a previous one, lab of number 1. So if you haven't finished it, lab number 1, please do it, and then we continue. So as in this lab, you will learn how to use SageMaker to build, train, and deploy machine learning model. We will use the popular XGBoost ML algorithm for this exercise. Amazon SageMaker is modular and fully managed machine learning service that enables developers and data scientists to build and train as well as deploy ML models at scale. So taking ML models from concept to production is typically complex and time-consuming process. It's really hard to do for data scientists, usually software staff, to prepare a model for production. Usually they would like to provide just a GPT notebooks that they put it into production and served like that. But with SageMaker, with Amazon SageMaker, we can avoid such pain points and do it quickly and briefly. So you have to manage a large amount of data and train the model, choose the best algorithm for training it, managing compute capacity while training it, and then deploy model into a production environment. Amazon SageMaker reduces this complexity by making it much easier to build and deploy models. After you choose the right algorithm, for example, XGBoost, and frameworks from the wide range of choices available, SageMaker manages all of this underlying infrastructure to train your model at petabyte scale and deploy in production. Yeah, we had a questions about how much data we can handle by SageMaker. So it's petabyte scales. In this tutorial, you will assume the role of machine learning developer working at the bank. You have to be asked to develop a machine learning model to predict whether a customer will enroll for a certificate of deposit. The model will be trained on the marketing datasets that contain information on customer demographic responses to marketing events and external factors. So, but I believe you have already keyed on to the dataset. Bulat have provided all essential information by a sophisticated way. The data has been labeled for your convenience, and a column in the dataset identifies whether a customer is enrolled for production offered by the bank. A version of this dataset is publicly available from a ML repository curated by University of California. This tutorial implements a supervised machine learning model since the data labeled. So let's take a first part. As you know, we have ECR containers. It is a Docker Hub repository inside of Amazon infrastructure, where we can just retrieve a specific container for XGBoost. I believe Rinat explained how it works and what it is. So let's run it. First of all, this cell. We get a container, the link itself. Then let's specify and train and validation data and set it locations through S3 links by the next cell. It's very fast and funny, I believe. So let's continue. Well, we need to specify several parameters. First of all, for the training, it will be algorithm, XGBoost. Then we have to provide EM role, what that the training job will use for accessing to all data or in infrastructure that we will be used. And then we have to provide for estimators as well, training instance type and count them. So for example, if you would like to use a large instance like for this GPU P3.2x, for example, that contain one V100 from NVIDIA, we can use several of these instances, even hundreds. So for training yourself, for example, GPT-3, for example. And also we have to provide S3 location for our output data and specify some algorithm hyperparameters. And of course, usual fit predict functions. That's so widespread between ML world. So first of all, session. It is session. The session will allocate session that where we will work with. Sorry. Do I still share my screen? Okay, let's go ahead. Thank you. Yeah, as you see, there is a container, role, instance count, instance type, output path, SageMaker session, so on and so forth. We can just switch from previous generation to the new one and move from ml.m4 to ml.m5.xlarge. So we can do the same in your cell and go next. So also we will provide some hyperparameters for XGBoost. I will describe it a little bit then. Give me a second, I just will run this cell. Yep. So as you see, training has started. First of all, SageMaker will create a specific instances, provision some instances, pull their Docker containers with a specific algorithm inside, then download necessary data, and only after that we'll start training. Usually this part takes, I don't know, maybe 3 or 5 minutes to start working with that. You can monitor this process through cell inside of SageMaker Studio. You see some kind of debugging logs like launching request, ML instances profile report, so on, and some specific ID number. And we see that it's in progress status. So also we can monitor this stuff by using SageMaker and SageMaker training stuff. You have to go to SageMaker, go to the SageMaker menu. Then on the left side panel, there is a drop-down menu training. Inside of this drop-down menu, there is a training jobs. Let's click to this link, and we will see the training jobs that we have run a few seconds ago. As you see, it's XGBoost, and it ran several minutes ago, and status in progress. When the status will be completed, we will have our models. Right now, if you have any questions, I see that there is unread messages, now chat, and some questions as well. Yeah. Please raise your hand, maybe ask your questions if you have any difficulties with running your model inside of SageMaker Studio. It will take about as I said, it will take about 3 or 5 minutes to train your model inside of SageMaker. Let's wait a little bit, and then we will continue deploying our prepared model. I have experience working with Kubeflow as well with SageMaker, and I have something to say that SageMaker much more easier to work with than Kubeflow because AWS provide a lot of Amazon maintain everything instead of you. It's very convenient than doing it yourself. For example, for working with Kubeflow, you have to maintain a Kubernetes cluster, you have to maintain all these nodes, and maybe something will go wrong because you will provide the wrong container and so on and so forth. Also, yeah, to work with Kubeflow, you have to know much more than working with SageMaker. So, but usually data scientists wouldn't like to work to know this stuff or even just to work with. But for them, there is a SageMaker. Okay, we have a prepared training job. It's finished. As you see, it was trained in 49 seconds and build. Sorry, once again, yeah, and we will build only for this 49 seconds. Yeah, but you know, this for provisioning will take about 2 minutes and no more than that. Okay, let's go ahead. Just look at the training jobs. We have status completed as well as inside of our SageMaker Studio. Okay, so right now we have a model and we prepare the model, and right now we need to deploy it. Let's do that. We can deploy our model by calling function deploy. We will provide some arguments to this method, like initial instance count, for example, number 1, and instance types. Let's change from M4 to M5 as well as we did it in a previous cell and run it. So this type of operation took usually much longer than previous one. I mean, in terms of provisioning instances, because Amazon have to do a lot of stuff under the hood. We will see a lot of dashes before exclamation mark. When we will see exclamation mark, it means that deploy has been completed. This thing, or in this operation, we also can monitor through SageMaker. Let's go to the inference endpoints, and we will see our endpoints that is trying to provision. Right now, we see that XG boost and status is creating. When the status is inserted, we will get ready to work endpoint. Let's back to our SageMaker Studio. So yeah, SageMaker endpoints provide a lot of stuff for you. It provides inference server, for example, HTTP, HTTPS, and all certificates that you need for that. You can just click this button and your model will be served. Also, it will run for you balances between your models. You can organize via SageMaker some canary deployment, blue-green deployment, and all other ops stuff. As I said, it will take a little bit longer than previous step. So this process can take around 6 or 8 minutes. Just wait a little bit. I'm happy to answer any of your questions if you have one. While provisioning is continue, we can discuss a little bit about evaluation. So in this step, we will reform our the CSV data, then run the model to create prediction. You will then evaluate model performance using confusion matrix in this case, we are predicting whether the customer will subscribe to a term deposit equals 1 or not equals 0. Is this our target value? first we will need to determine how we pass data into the received data from our endpoint. Our data is currently stored as an NumPy arrays in memory of our notebook instance. So we have to convert it to CSV, and then when we get the result, just decode it from CSV to NumPy array as well. And we do it through CSV serializer inside of SageMaker serializers. Also, you can use any other models instead of XGBoost, for example. You can provide any other gradient boosting trees like CutBoost or LightGBM and other models that's so well known by most famous Kaggers for table data. Let's look into the audience. Is there any questions? Not so far. Just wait for the finish of deployment. So yeah, then we have to write some kind of function for prediction, where we will loop over all our test data set, split into mini batches of rows, convert these mini batches to CSV strings payload, as I said before, then send it to our estimator through calling method predict, providing an array as a string, retrieve the result, and convert it back to NumPy array. Yeah, I just have to mention that we shouldn't include the target variable into estimator. So for that, we just remove these columns, target no and target yes from our test data set. Yeah. Endpoint is enabled in service, it's ready to go. And there is an exclamation mark. Let's run the next cell, CSV serializer. Then run predictions. So it made very briefly, and we already get the results. So let's look at this data. Okay, you see cross tab. We see that's on training on 49 seconds, we get a pretty good results with low first-second errors. From our 4,000 potential customers, model predicted 42 would subscribe, and 94 of them actually did, but also had 389 subscribers who actually subscribed that model did not predict would. So yeah, for me, sorry, I said 53 model predicted would subscribe, and 101 of them actually did. But also 382 subscribers who actually subscribed that model didn't predict that they would. I believe that's everybody finishes that models, these steps. So we will be run out of our time. Therefore, just maybe stop it here. I just maybe add some tips of using SageMaker Studio. This is a very sophisticated solution. I mean, in terms of, it's not just a Jupyter notebook or Jupyter lab. It consists a lot of helpful stuff like Jumpstart, console, and comprehensive. You can monitor every your models inside of this SageMaker Studio. Also works with Git version control. And as far as I remember, it provides some helpful tips for you if you don't want to work, for example, with to type your own function for, I don't know, calculate median for some kind of data, or drop the data from pandas, for example. You can use this helpful snapshots from SageMaker Studio. From my side, I believe that's it. You can maybe get a very little bit different result from my crosstab, and because maybe some initialization in XGBoost was a little bit different during the training, but it's not so vital right now. Yeah.
Hey, Rinat, there is a question saying, can you show where the endpoint gets deployed? How do you check it? Could you just show them?
Yeah, of course. Let's go from the beginning. We type SageMaker, go to SageMaker menu, then inside of SageMaker, on the left side panel, there is a drop-down menu endpoints. Oh, it takes forever to open. There is some issue with internet, I believe. Yeah. Yeah, there is a drop-down menu inference where we can find endpoints. Just click to the endpoints and you will see all endpoints that have deployed. And yeah, pay attention that they should be in server status. Any other questions? Yeah. Okay, I have another questions. To make change to the model, do we need to run all steps with changes? Depend on what changes have you made. If you changes only your model, for example, replace XGBoost by linear model or any other one, you just need to replace this step. I mean, give me a second. Yeah. So you have to train data on, if your data hasn't been changed, you can continue from this step, estimator, providing container, and so on and so forth. If you changed your data, you have to work with the previous steps as well. But also, please do not forget to remove all of your endpoints and then of your work, for example, or if you wouldn't like to deploy them after your development. So for that, we just need to scroll down at the bottom of the notebook, and where we will see XGB predictor. And there is a method called delete endpoints, and we just run this model. After that, let's go to the endpoints, and you will see that there is no resources at the moment. So we clean up our environment. So I will wait for another questions. How do we use the tool for deducting bias? Yeah, I believe that it should be covered by Rinat, another Rinat, in a previous lecture.
Yes, I can take that, Rinat, if it's okay. You can detect bias using Clarify, as we covered in the section. And Clarify is available within this environment, studio environment. We don't have time to go through the instructions, but I can share a link to the documentation and it can tell you how do you set it up. And it's fairly straightforward. It integrates with a lot of these services within the studio. So to your question, I can just post the link of how you can start working on that. And if you look at the lab instructions, there is a lab session for bias, which we didn't do. So you could just go through that and play around with that as well.
Okay.
Rinat, there is another question if you want to take it. Can we display accuracy, precision, etc. for the model through the code at the end? I'm assuming they're talking about SageMaker Notebook. How would you start printing
Yeah, accuracy, precision, etc. for the models through the code at the end. Yeah. So yeah, precision and recall is mostly for classification problem, and yeah, as we did it right now. So as far as I know, we have such code inside of GitHub, inside of Jupyter, inside of notebooks that we will be shared with you after the lab. Does it cover your questions?
So another way to look at those metrics is also through, if you're talking about training, if you look at when you run the cell, it actually displays a lot of CloudWatch logs, and there it'll actually display your validation metrics, your training data metrics. So that is also one way to look at it. I know there's tons of logs.
Yeah. There is a question about if we delete the endpoint, the model is still deployed, right? So this endpoint is the server model itself. It means that if you call the function in the end of the notebook, exhibitor predictor delete endpoint, you will stop all instances related to your own endpoint and deploy the model itself. So SageMaker will automatically stop all instances, delete your model, and will not charge you for that. So as far as I said, any guidance tips on AWS ML certification? There is a good documentation from AWS, where we can find all exam questions and prepare information, handbooks, so on and so forth. Also, you can take any pre-able courses for that, where they provide all necessary information for that. For example, Guru Lab, for example. And so, yeah, this is my advice or tip. Yeah, just try hard. It's every time. It's not a waste time. You can will reach the goal. Is there a way to run CNN models such as TensorFlow sequential API? Yes, of course. For example, for TensorFlow and PyTorch, there is a specific algorithms and containers inside of SageMaker. So for that, you can just look at to the lab number 4, as far as I remember, where you can run your specific model. Oh, there is several ways how you can deploy a model. For example, it could be built-in models like XGBoost or any other models inside of SageMaker. It could be your own model in PyTorch, TensorFlow, MXNet, for example. And there is a function as, let me find it out of here. Where is it? So instead of estimator, you will write something like PyTorch, for example, or TensorFlow. Where is it? A little bit above. Yeah. And this is a way how you can run the model. It will look like SageMaker, estimator, and PyTorch. Something like that. You can provide CRC. This is the path to your code. Also, inside of this CRC, this path should be requirements.txt, where you can, when you will train your model, it will install all necessary requirements and then continue training. Any other questions? So there's no questions. Thank you very much for your attention. It's a pleasure to me. Oh yeah, we have any other questions? Yeah, is there a facility to compare performance of 2 different algorithms, like XGBoost or linear regression on the same data, and then we can choose the model? Of course, you can do it. You can train on 2 different models, then deploy on via endpoints and run the code for choosing the best one. So you just change a little bit function of prediction. So we have a predictions for example, for model 1 and for model 2, and then just elaborate on this data. Figure out which results is the best. So I just think if I will say that's it from my side, I'm just a little bit run out from my time. Somebody will pose the questions, but it's very pleasure to me to answer questions. Okay, thank you for fabulous time. That's it from my side. Who would like to take a word? And would be a next presenter. Maybe Yaroslav?
Yeah, thanks, Rinat. That's a great session. Thank you very much, everyone. Yeah, and since it's coming to an end, we have prepared a quick value proposition for you. I'll still share my screen. Just give me have another 5 minutes to spend on it, not more. Okay, I hope you can see it. All right. So now that you have all the knowledge and skills for moving forward with the machine learning on Amazon SageMaker, here is the next step for you to get started as an organization. So here is what we've prepared for you as a, sorry, the slides are not, yeah, you can see it. Here's what we've prepared for you as a company. So if you're part of an organization that currently has an ongoing ML initiative, Provectus and AWS have jointly developed a machine learning acceleration program. It is designed to help businesses build a robust machine learning infrastructure to accelerate AI adoption enterprise-wide. Like in simple terms, it's a combination of pre-built quick starts, reference architectures, in-person workshop, and funding opportunities provided by AWS. So we are ready to work with your leadership team to align your company towards a North Star machine learning architecture, processes, and culture. So you can tap into benefits we have highlighted during this webinar faster and with less upfront investment. This offering is available for a limited number of customers and is a fully funded engagement. Please use the link I will share with you right now in the chat so that you can apply for the program. Just give me a second, please. Yeah, here you go. You can use this link to apply for the program. It will also be shared with you in the follow-up email after this session with the webinar recording. All right. Thanks again for your time spent with us today. Should you have any questions, please keep using our publicly available Slack channel. We'd be happy to follow up with you thereafter. And we are really happy to have you today. Any closing notes from AWS team?
No, thank you. It was great partnering with Provectus, and I hope all of you learned a lot from these sessions. Thank you so much for joining us.
Yeah, thank you very much. Bye now. Thank you.